Good morning. The last class we learned how to draw a flow net for a sheet pile wall. So in this class, let us learn how to draw flow net in case of concrete dam and earthen dam. The first figure here shows that concrete dam with cut-off wall, without cut-off wall. So there is no obstruction here below the base of the dam here for the flow of water. Hence there is no cut-off. Cut-off means to cut the movement of water. We provide the wall. It is called as cut-off wall. So we can see here. So we have selected 4 plus 1 5 flow lines. It is boundary flow line, and another 4 flow lines, and the equipotential lines. So this is the typical format of the flow net, and the typical flow lines and equipotential lines for a concrete dam without cut-off wall. Then second figure shows the concrete dam with cut-off walls. So here you can see there are 2 vertical walls here, both at the heel and the toe. Cut-off walls are required whenever the flow below the dam is a considerable one. If soil is too much pervious, in order to reduce the flow of water and or seepage of water through the below the bed of the dam, so they provide the cut-off walls like this. Cut-off walls, maybe it is a concrete cut-off wall or a steel cut-off wall, that depends upon the depth and the requirements. So in case of cut-off walls both at upstream and downstream side, or both at heel and toe, so flow lines and equipotential line patterns are like this. You can see so this is the boundary equipotential line, and this is the boundary flow line. You can see a number of flow lines here, 1, 2, 3, 4. So there are 1, 2, 3, 4 number of flow channels. So in the previous case also there are 1, 2, 3, 4, 5 flow channels, and number of equipotential line you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. So there is a little the kink here in the flow lines. There is reduction in flow, hence there are no flow lines here, and you can see also here that the flow lines becomes mild as we move away from the cut-off walls. The next figure you can see here, a concrete dam with cut-off wall only at the upstream heel portion. If the seepage below the dam is it's a moderate one, this is seepage is more, and this case seepage is moderate one. Under that circumstance, we can provide a cut-off wall below the dam at the heel portion. So for that the flow lines and equipotential lines patterns will be like this. And again, once again, here it is this is the boundary equipotential line, and this is the interface between pervious and impervious strata is known as boundary flow line. The last one is the earthen dam with the horizontal filter at toe portion. You can see here upstream side, downstream side, and this is the storage level. Generally we call it as a full tank level or full dam level, full reservoir level, or maximum water level, something like that. So in order to we know that it is highly impossible to have the structure without any seepage. When that is the case, whatever the water which enters the dam, particularly earthen dam, should be safely removed. Otherwise, the water entered will create problem to the portion of the dam. So in order to remove water safely at the downstream end of the dam, is called as a toe portion of the dam. We provide a graded filter so that whatever the water which enters the dam and which will leave the dam without harming the dam portion, and that is called as graded filter or horizontal filter at the toe portion. The function of this filter is that it should avoid the migration of finer particles of the dam soil and air, and also it will permit the free flow of water so that there shall not be any building up of hydrostatic pressure. So both are not desirable from the safety point of dam. So it should not permit the free flow of water. At the same time, it should not there shall not be any building up of water pressure. So filter material should not be so too coarse. Too coarse means there shall if the material is only coarse, all the fine particles will come and fill up the voids, and hence it block the flow of water. That is not permitted. Again, if the voids are very less, then there is a chance of building up of water pressure. That should also not permissible. So both the case should be avoided. There shall be free flow of water in the filter, and there shall not be any building up of hydrostatic pressure or pore pressure. So from safety point of view. So like this you can draw the flow net, flow lines and equipotential line. These are all the typical the flow nets. Wherever we require, the same flow net can be repeated for the given boundary conditions. As I already discussed, that boundary conditions means the hydraulic structure. So this is its dimension known, and the ground level. Next, other one is interface level is the line between pervious and impervious stratum is known as interface. So these are all the boundary conditions. After fixing the boundary conditions, we can decide the flow lines and equipotential line and complete the flow net. Similarly here, in case of cutoff walls also. So boundary conditions, dam section is known, then ground level is known, then again interface between the pervious and impervious strata is known. Knowing these boundary conditions, we can decide the flow lines and equipotential. Likewise here, in case of concrete dam with the cutoff wall at the heel, and in earthen dam also, knowing the cross section of the dam and the water level, then the boundary conditions, this ground level, we can decide the flow lines. This one again, there is some more things to be added here. We will take up in the next topic, how to locate this topmost line is called as the Phreatic line. In the case of earthen dam with horizontal filter at the downstream side and without horizontal filter at the downstream side. So having the idea about the flow net means how to draw flow lines and equipotential line for various condition. It is starting from one is the sheet pile wall, then it is a concrete dam without cutoff walls, concrete dam with cutoff walls, concrete dam with cutoff wall at the heel, and for earthen dam we can use these typical flow nets for application purpose. So whenever we require to draw flow net and to find out the seepage or seepage discharge or hydraulic gradient and quantity of seepage, so you can proceed. Next, method of locating phreatic line in the case of earthen dam with the horizontal filter. At the downstream. In most of the problem concerned with the seepage, the hydraulic boundary conditions are known or can be easily assessed. But in the case of flow through the earthen dam, the boundary condition, particularly the seepage line, the boundary seepage line such as the phreatic line is difficult to assess, and hence we adopt a graphical solution to locate the phreatic line in the case of earthen dam. Phreatic line is the line in the earthen dam. Below that line there is a positive hydrostatic pressure, and above the phreatic line there is a negative hydrostatic pressure. So one such method of locating phreatic line in case of earthen dam with horizontal filter, let us discuss now. First of all, we have to draw the cross section of the dam to a suitable scale. Also, I have to draw the horizontal filter at the downstream side to a suitable scale. Then to mark the water level, so usually this is called as full supply level or full reservoir level. So these are the boundary conditions. So knowing the height of the dam and the upstream and downstream slopes, we can construct this dam cross section to a suitable scale, and also we can construct this the horizontal filter at the downstream side. Next, let us mark the intersection of this the ground line and the upstream face of the dam as A, and this point as say this intersection point as say B. If you project point A to meet the horizontal water surface, you get C. Here BC is represented as L, small l. Select another point D at a distance 0.3 times of L from B and locate point D. This point D is known as theoretical commencing point of phreatic line. So, on the water surface, point D is known as the theoretical commencement of phreatic line. Produce this the water surface horizontally to extend towards the downstream end of the dam. Next, mark the commencing point of the filter as say F with D as center, DF as radius, draw an arc to cut the horizontal line produced at point M. From M, draw a tangent to this arc from M to meet the horizontal filter at N. Bisect Fn at G. So, G will be the last point of phreatic line, on the horizontal filter. Next, in order to obtain the smooth curve of this phreatic line, if we can locate the intermediate points between the actual commencing point of phreatic line B and G. For that, select any distance or any point say P, P1 at a distance x from F, x1 from F. From P1 drop a perpendicular and produce in the upward direction. With F as center, Fp1 as radius, cut an arc, and this is P1 dash. Let us locate another intermediate points. We can locate any number of intermediate points. To locate another intermediate points, again select another point say P2 at a distance say x2 from F. Next, with F as center, Fp2 as radius, cut an arc. So, this is P2 dash. Likewise, you can mark any number of intermediate points between the commencing point and the end point of the phreatic line. Then, after marking the intermediate points, we can draw the phreatic line. So, phreatic line should commence from B, not from D, because though it is D is the theoretical commencing point of the phreatic line. So, even then we can draw it as like this. Can see here phreatic line D is the theoretical commencing point of phreatic line and B is the actual commencing point of phreatic line. It has started at point B and it is perpendicular to the boundary equipotential line. So this is flow line, phreatic line is one of the flow line and this is the boundary equipotential line. Flow line and equipotential line meeting at right angles to each other, you can see here. Then it has connected the intermediate points. Finally, this flow line will meet the boundary. So this is the boundary line like this. So this is the meeting point of this the flow line. This flow line that is fine, and finally it will leave the dam portion. So this line is known as phreatic line. Can also be called as saturation line. So phreatic line is the topmost flow line within the dam section. Below this line there is a positive hydrostatic pressure and above this line there is a negative hydrostatic pressure, means it is almost same as that of the dry condition. Upstream side and this is downstream side and this is tangent, vertical tangent we can say, it is vertical tangent drawn to the arc. The horizontal filter distance between F and S is known as S. F and N is known as S, and again the horizontal between F and this distance, horizontal distance, is known as small b, and let this height of water as h. So after obtaining phreatic line or saturation line, we can easily calculate the quantity of water flowing through the soil. So quantity of water flowing through the soil, Q is equal to K into S, where K is equal to coefficient of permeability of soil and S is equal to the focal length. K is equal to coefficient of permeability, S is equal to focal length, that is S is equal to root of B square plus H square minus B. So B square is the horizontal distance between the theoretical commencing point of the phreatic line and the commencing point of the horizontal filter. H is the head of water at the upstream side. So like this we can locate the phreatic line in the case of earthen dam with the horizontal filter at the downstream side. Sometimes dams are also constructed without a horizontal filter at the downstream side. For that also it is we can draw a phreatic line. Next, locating a phreatic line in earthen dam without horizontal filter. At the downstream side. So, in this case also first of all you have to construct the earthen dam to a suitable scale. Then mark the water level, mark point A at the upstream side and B also at the water level. Produce a point A in the upward direction to meet the water level. So, let BC be the length L. Take 0.3 times of L as D. Which is the commencing point of phreatic line, theoretical commencing point of phreatic line. Next, consider the downstream end. This is called as a toe portion as F. With D as center, DFS radius, draw an arc to cut the horizontal line produced at point M. From M, drop a perpendicular to meet the ground level at point N. Bisect Fn at G. So, G is the last point of the phreatic line, and here B is the actual commencing point of phreatic line and D is the theoretical commencing point of phreatic line. Next, in order to locate the intermediate point between B and G, say measure x1 from F, drop a perpendicular with F as center, P1 as radius, draw an arc to cut the vertical line produced from P1, say it is P1 dash. Similarly, select any other point, say P2 at a distance of x2. And draw up a perpendicular and extend the line in the upward direction. With F as center, FP2 as radius, cut another arc. So this is the second intermediate point of the phreatic line. Next, complete the phreatic line. To draw a phreatic line, the phreatic line should commence at point B, not at point D. So as the actual commencing point of phreatic line is B, so you can see the actual commencing point of phreatic line is B, not at point D. So phreatic line runs smoothly in the form of parabola or ellipse, and it will again there is the tendency of emerging out of the dam at point, you can call this as point as say J. However, in actual practice this will not happen. Instead, the phreatic line will merge the dam portion at point K and continues with the downstream slope of the dam, and it will merge, actually it is at point F. So the portion of the dam from J to F, it is remains wet, hence it is called as the discharge phase. So this phase is known as discharge phase. The amount by which the curve shifted can be obtained by using the Casagrande's graphical solution, and this is called as delta A. So this is a vertical tangent. Downstream, upstream. Phreatic line. And this portion we call it as toe. Ground level. So procedure, almost 80% of the procedure is same here to locate the phreatic line as in case of location of phreatic line with the horizontal filter, that here we locate point C, then point D at a distance 0.3 times of L. D is the theoretical commencing point of phreatic line, and actually the phreatic line will start at point B. With D as center, DF as the radius, F is the the toe point, the last point of the downstream corner of the earthen dam. So the slope, where the slope intersect the ground surface, that's called as a toe portion. With D as center, DFS radius, draw an arc to cut the horizontal line produced in the down horizontally at point M. From point M, draw a vertical tangent to meet the downstream horizontal line at point N. Bisect Fn at point G. G is the last point of the phreatic line. In order to obtain smooth curve, we can locate the intermediate points between B and G. For that, select any arbitrary point, say P1 at a distance x1 from F. Drop a perpendicular at point P1, and with F as center, Fp1 as radius, cut an arc, that is P1 dash, the one intermediate point. Likewise, we can locate any number of intermediate points on the phreatic line in order to obtain the smooth curve. Next, join the points B from point B to point G by means of a smooth curve, you can see. So phreatic line will meet this the boundary equipotential line at right angle. Similarly, the same phreatic line will meet the ground surface at that right angle. You can see there is a tendency, again there are two theoretical portions here. One is the theoretical commencing point of phreatic line, again theoretical ending point of phreatic line. But in actual practice, so the phreatic line will start at point B and it will merge at point K and continues up to the toe point. So this the portion between J and F is known as the discharge phase, always, because the water or the saturation line or phreatic line merge with the downstream slope of the dam portion, always this becomes a wet. The portion by which the theoretical phreatic line is merging with the downstream slope can be obtained by using a graphical Casagrande's graphical solution delta A and A. Again here also we can calculate quantity of seepage. Q is equal to K into S, where S is equal to the focal length, that is between the horizontal between N and F is called as S, and the horizontal distance between horizontal distance between the commencing point of phreatic line and the commencing point, the toe is known as B, and H is the height of the water or head of the water at the upstream side. Therefore, quantity of seepage Q is equal to K into S, where K is equal to coefficient of permeability, S is the focal length. This focal length can be obtained by using the relation S is equal to root of H square plus B square minus B. So like this we can locate the phreatic line. In the case of earthen dam, with the horizontal filter and without horizontal filter at the downstream side. So this is all the theoretical portion of this the Flownet, and we can take up numerical problems in the next class.